What's up, AP Calculus students? It's your boy Shinwoo here, and today I'm going to be taking the role of the instructor in the topic of mean value theorem, MVT. And we all know that only MVPs know the MVT. So we all want to be MVPs, so yeah, I got a lot of fun stuff, so let's jump into it. Alright, so the mean value theorem, it actually has a couple requirements for it to work. So the first one being that the function has to be continuous, and the function also has to be differentiable. So what differentiable pretty much means, as a little review, is that you have to be able to find the derivative at every point in the function. And also the last one is the function has to be on a closed interval. So right here, from point A to point B, it has to be in a closed interval. And what the closed interval pretty much means is that the function has to be defined at every point in between A and B, and also including at A and at B. So essentially what a closed interval really means is that if I draw a little x and y axis here, so if I have the function from point A to point B, just any function, then the function has to be defined at every point in between A and B, so all of this, and also including A and B. So yeah, once again, you would write that as like so. So what the mean value theorem states is that if the function is defined at closed interval a comma b, which pretty much means that it's defined from point A to point B, also including the points A and B, and the function is also continuous and differentiable, then there must be some point C that in between A and B, that the f prime of C, or the derivative of C, and the instantaneous slope equals the average slope of the function defined at a comma b. If we have our function here from point A to point B, that there must be some number c in between A and B that the derivative of c is equal with the average slope of the function defined at a comma b. So if we draw the average slope from this point to this point, that's our average slope. Now, there's going to be some point C along this function where the tangent line is going to be the same as the average slope. So let's say this point right here, and looks like this point right here. So that means that at this point and at this point, the instantaneous slope, and so the f prime of c, is equal with the average slope of the function defined at A and B. So how do we find the average slope? So the average slope, we use the formula f of b minus f of a over b minus a. So what is that? So let's say that this is our function, so like that, and this is point A and this is point B. So the average slope would be from point A to point B. That would be our average slope. Now how do we find that? So basically the average slope is rise over run. And let's say this is our run and this is our rise. So we take, let's call this point A f of A, and this B f of B. So if to find the run, we would take f of B and subtract f of A. That would give us the rise. And to find the run, we would take B and subtract A. That would give us the run. And then we would do rise over run, which is f of B minus f of A over B of A, and that would give us our average slope. So let's try some practice problems. So we got a simple little function here. We got f of x equals x squared plus 2x, and the function is defined at closed interval 2 comma 4. So what we need to do first is we need to find the average slope of the function. So to find the average slope, the formula once again is f of b minus f of a over b minus a. Now, f of b, we take 4, and then we plug it into the function. So if you plug 4 into the function, that would be 16 plus 8, so that would be 24. And to find f of a, we plug 2 into the function. So if you plug 2 into the function, that would be 4 plus 4, so that would be 8. And b minus a is just 4 minus 2. So we got all of our numbers here. So we just do the simple math. So that will be 16 minus 2, which would give us 8. So 8, that is our average slope. Now, since we found the average slope, which is 8, we need to go on to the next step, which we find the derivative of f of x. So the derivative of f of x, so f prime of x, is 2x plus 2. Now, we need to set the derivative of f of x, which is 2x plus 2, we need to set that equal to the average slope, because we said that the f prime of c, which in this case is x, f prime of c equals the average slope of the function. So this is the average slope, which is 8, and we set that equal to f prime of x right here, and we solve for x, which is x is going to be our c, and that's going to be our point in the function where the tangent line is parallel to the average slope, which pretty much means that at that point the instantaneous slope is equal to the average slope. So to solve for x right here, we would do subtract 2, that would give us 6, and then x would equal 3. So we found x right here. X equals 3. So that means that at 3 in the closed interval 2 comma 4, the instantaneous slope is equal to the average slope of the function. So a good thing to remember when you're solving for the x value is that you got to remember that the x value has to be in between the interval. So in this case, we have f of x equals 3x cubed plus 2x squared minus 1. So you find the average slope with the formula f of b minus f of a over b minus a, and you would get 7. And then you would find a derivative, and you set that derivative equal to 7. And in this case, x would be equal to more than one answer. There would be more than one value for x. And you got to remember that you could cancel out some x values if they are not in the interval, in this case the interval -2, comma 1. And if they are in the interval, then you found your value. So yeah, that's it for my part here, teaching you a little bit about the mean value theorem. As you guys might have found out that the mean value theorem isn't as mean as it might have sounded at first, but yeah, I know you guys are all super smart calculus students, so you guys probably already got this in the bag, but if you guys feel like you need more help or you need more practice, you could head over to the worksheet I made. It has a variety of practice problems that you could utilize the mean value theorem in, and you know, practice makes perfect, so there you go. Anyways, good luck to you all in the future, and always remember the MVT. See ya!